Let's talk about IoT and robotics. Sorry for the corny title. I feel this urge to have some kind of pun in the title of a presentation to make it catchy. So it doesn't really make sense, but it's up there now. Can't change it. So what we're going to be talking about today, what is the Internet of Things? Let me actually back up a step. We're barely going to scratch the surface of this, right? So Internet of Things in general has branching rabbit holes that go almost infinitely deep, and there is no way we have the time to cover it all. Not to mention, I can't cover it all. So we're going to talk about what is the Internet of Things at a pretty high level view. What are the elements of an IoT infrastructure? How can IoT be applied to robotics? And if you wanted to kind of dip your toes into implementing IoT concepts in manufacturing or production, what are some of the ways to do it? So a brief primer on the Internet of Things. At its core, really, it's about data, right? It's about connecting devices and having them share data back and forth. The hard part isn't collecting the data. That's been around for years. At this point, it's more or less trivial. The hard part is determining where and how to push that data, right? So getting your data out of wherever it's being stored, interpreting it in a way that's relevant to your processes, and sharing those results with the people that can use it in whatever capacity. So in a nutshell, it's getting information to the consumers of the information on any device. I feel like I should clarify that a little bit. It's not quite information, it's data, right? Information is, it can be whatever. Data is meaningful, right? So that's that one small clarification there. Super high level basic terminology. IoT is the Internet of Things, obviously. Industrial Internet of Things, there's some subtle but important differences between IoT and IIoT. IoT covers things like a Nest thermostat. If you go into Best Buy, you can buy a fridge that you can send a mean tweet from. Consumer level stuff falls into IoT, right? Fitbit is an example. Industrial Internet of Things is much more geared towards production and manufacturing. So things like latency, bandwidth, who is accessing the data, what decisions can they make based on it, all those play a much bigger role in an IIoT system than just generic IoT, right? So I guess kind of like all tigers are cats, not all cats are tigers. IIoT falls into IoT, but not all IoT is industrially robust. There's also a concept called Industry 4.0. It's a strategy conceptualized and pushed by the German government. It's intended, in a nutshell, it's a smart factory. It's intended to be the fourth industrial revolution. The counterpoint to it being a revolution is that what they're pushing, interconnected devices, decentralized decision making, pushing the information out to the operators and letting them make the decisions, that kind of thing doesn't really happen overnight, right? So I was talking with Carl Benz, and he gave me a really good example. The self-driving car will be a revolution in automotive technology, right? It's going to change a lot of things. It doesn't really happen as a revolution, though, because there's a bunch of tiny little steps that happens incrementally. So it's not like, okay, we have these 4 principles, turn your factory into a smart factory. It doesn't really happen like that. There's hundreds of steps that need to happen before that. So basic terminology there. One of the key things about an IoT infrastructure is the concept of the cloud. I feel like pretty much everyone in this room knows what it is. I say it's not a physical thing. It's only really half true, right? It's a system of servers somewhere. It just doesn't need to be on your location, right? So fundamentally, what makes the cloud from the end user's perspective is that you don't actually own the servers, you're just using it for a fee, whether you know it or not. Even if you have a free Gmail account or a Google Drive, you're paying them with data, with your own data, right? I kind of stole a definition from Microsoft as like a textbook definition. It's a network of remote servers connected and configured to operate as a single ecosystem. Anyone use Google Drive? That's not, so you can use Google File Stream and keep a copy of everything locally, but you don't need to, right? And you can get to a Google Doc from your computer, a tablet, from your friend's computer if you log in. That document doesn't exist on your hard drive. It's out in the cloud, and it can be accessed from almost any device. You can probably get to it from your fridge if you wanted to type it, get ice or something, I don't know. So information is available to any device on the network. The nice thing about the cloud, why is this so important, is because it's much more scalable than having a local on-site physical server farm, right? So, and even at any particular scale, it's much cheaper to use existing infrastructure owned and maintained by somebody else, and just use the storage and the bandwidth and the transmission than building all that physically yourself. And like I said, not about getting data into the cloud. Some popular cloud services that are used commercially are Amazon Web Services, Microsoft Azure, and IBM Cloud. I can't think of any examples of IBM Cloud usage. I just know it's one of the big ones. I'm pretty sure Netflix runs on Amazon Web Services, so they're extremely data heavy, right? And they're a major player in streaming content and getting tons of data out to different devices. Amazon Web Services is what runs all of that. Another important concept, I'll preface this by saying, I haven't been able to find a solid definition on edge versus gateway, okay? So, I'll give you a preliminary definition. The edge is the boundary between the local network and the devices. It can also mean the furthest device on an IoT system from the cloud, where all the big data storage and processing happens, right? So if you think about a temperature sensor, that's an easy enough example. If you think about a temperature sensor, that is the very, very last thing on the fringes of your IoT network, right? It's not doing much more except for collecting data and transmitting it. It basically serves as the connection between your sensors, controllers, devices, and the network. You could also say it's the connection between your physical world and the cloud, basically, or your entire IoT system. A gateway is the boundary between your local network and the cloud. Okay, so an example most people should be familiar with, if you think about a router, in your home network you've got the modem and you've got your router, right? A close approximation would be your router as an edge device, or even, let's say you've got a PlayStation connected to your router. PlayStation would be the edge device. Router could be called an edge device. It collects all that information and pushes it. Your modem would be the actual gateway, because you can't connect to anything outside. It is literally a gateway between your ecosystem and the cloud at large. A couple of different types of edge devices. There's thin, intelligent, and then actuated. Thin is temperature sensor, accelerometer. It's the bare minimum of what an edge device can be. Basically, all it does is collect and communicate information, like I said. You can't program it really to do anything, to be a thin device. Intelligent devices, there's sensing and communication, just like in a thin device, but you can also have some simple processing capability. So a smart electric meter can do some pre-processing of the data before it pushes it further towards the cloud, right? You can reprogram it to do something slightly different, but the major processing still happens off-site on your remote servers. Actuated devices, they're the same as an intelligent device, but they can actually take actions, actuated, right? There's two different types, static and dynamic. Static is simple actions. Think about your Nest thermostat, right? It's collecting all your temperature data, doing some pre-processing of it, pushing it out to the cloud. Then it can take actions based on your peak usage to make your home more efficient, or whatever facility. Dynamic, in a nutshell, it can do much more advanced operations. What's an example of a dynamic actuated edge device?
The VR?
Yeah, it's a robot, right? So a robot is a collection of sensors and actuators and servos, and they all feed back to each other, but it's really a collection, it's like a higher level system of sensors and actuators, right? So a robot on your IoT infrastructure would be classified as an edge device. I'm not an expert on protocols, okay? But basically, when you have such a diverse array of devices on an IoT network, you have what is colloquially called a basket of remotes problem, right? If you have, at home, if you have a TV, a DVR, whatever, a dish network box, you don't want to necessarily have 100 different remotes sitting in a basket, and then before you actually do anything with your expensive entertainment system, you got to dig through and find the right remote, right? It's much better to have a universal, one thing that can talk to all the devices. But like with edge devices, remember how I said industrial Internet of Things, your network capabilities come into play. Even with your protocols, you have to balance the capability, as in what you're trying to tell your devices to do and the information you're collecting, the power draw, and the bandwidth. There's a few new protocols that have been adopted. I'm not going to go too much into any of these because I doubt that's that interesting. MQTT is very, very light, but you can't do a lot with it. So basically you can communicate data, but you can't do a lot of programming. It's really good on power draw and light on bandwidth, right? So if you're constrained by your bandwidth, you don't really need to do a whole lot of complexity out at the edge. MQTT might be a good option. AMQP is a little, one of the things you can't do here is you can't queue up messages, right? AMQP, you can queue messages. It's a little more advanced. It gives you fine-grained queuing control. Inherently, it's going to be a little more of a bandwidth hog and a power hog. JSON, it's an object-oriented language. Like I said, I'm not an expert on any of these. I just want to put this in front of you guys so you see the terminology. An edge gateway, really what it's going to do, it's going to take all these different protocols that are being used by your edge devices, convert them into some kind of more universal protocol so that it can be processed efficiently in the cloud. That's a simple way of looking at that. So an overview of your infrastructure, you've got your edge devices, which are your sensors, a collection of all that makes your facility, right? And then through your gateway, you push all this to the cloud layer, all your big analytics, and I call it data ingestion. It's basically shoving the data into the cloud, into whatever computational engines you have, and then pushing it out to all the devices wherever they're needed. Two main uses of all this in manufacturing. One is production optimization. What does that really mean? Well, it can mean two further things, right? You could increase throughput or reduce costs, right? By basically tuning processes. So Microsoft had a smart campus. They reduced energy consumption by $6 million a year. They already had all the sensors in place, so they didn't need to go add a bunch of new sensors or anything. They used their existing edge devices, pulled it all together with an IoT infrastructure with gateways and cloud computing, basically, and optimized their energy usage and saved a boatload of money. Diagnostics and preventative maintenance is the other use. With robots specifically, you can collect the sensor data and figure out when you might need to run some maintenance, right? So a robot, any mechanical system, is going to have some kind of wear, right? Like components where you do need maintenance at some point. Now, do you want to be able to plan for that maintenance, or have it just pop up and all of a sudden you have unplanned downtime? Well, the other alternative is scheduled downtime. You run maintenance on a schedule, but you're going to be running maintenance sometimes when you don't need it. You might be running it too early or even too late. So being able to collect and analyze the sensor data could let you know ahead of time when some kind of issue, maybe not imminent, but you know, your sensor readings are trending out of the normal range. Multi-layered systems. Like I said before, a deployed robot, it's really a system of smaller devices, right? And they all work together to make a higher order system. A manufacturing environment with a bunch of systems can form an even higher level system with its collection of robots. Most robots are actually capable of acting as gateway devices if you configure them properly. The pre-processing capability isn't necessarily always available on a robot out of the box, but the capability to connect to a network and push data, usually there on a robot, certainly is on the UR. This is kind of a disjointed slide, but I wanted to make sure I mentioned this. This is my very funny joke. So contrary to popular belief, artificial intelligence or machine learning isn't a million if statements like you see there. It's not just if this particular scenario happens, do this, right? It's actually a learning process. This is kind of, I said earlier that a robot doesn't do what you tell it to do, it doesn't do what you want it to do, it does what you tell it to do. Machine learning is closer to what you want it to do, right? But one of the things is you can't plug in a machine learning system and have it work right out of the box. So in order to learn what you want it to do, you have to tell it, you have to demonstrate what you want, right? Just like people. You can't tell someone to do something for the first time ever and have them immediately go through and do it. They need to fail, they need to go through many, many iterations, and slowly they'll start to recognize patterns in what is good and what is bad. Same thing with machine learning. If you're doing visual inspection of something, with the traditional approach would be image matching, right? So if I need to verify that the cap is on the bottle, I show it a picture with the cap on the bottle, and if it sees that, it doesn't match. So it's basically binary. Machine learning would be if I need to train it for defects on a surface, just for example. I need it to check for smudges, defects. I don't know exactly what kind of defects I might have, but I know what a good part looks like. Some parts might be acceptable. So you basically show it thousands of different samples, right? And for each sample, you have a person actually say, this is good, this is bad. That's ultimately all you need to say is, this is good, this is bad, this is good, this is bad. Eventually it figures out what the patterns are and learns what makes a good part and a bad part. So now when you show it something that wasn't part of the samples, it has a much higher chance of guessing whether it's good or bad. With cloud analytics, the gathering and pre-processing of huge amounts of process data is making machine learning more and more feasible. The key kind of is to pick your application properly and determine whether it needs machine learning. It's totally feasible right now in terms of just raw capability. It's whether your process necessarily benefits from it a great deal, whether your infrastructure is in place that requires a lot more inspection. Another use of IoT in robotics is networked robotics. Self-driving cars, again. Google self-driving cars, it doesn't have a map stored on a hard drive somewhere, right? It's constantly communicating with their servers, constantly looking at traffic data. Y'all use Google Maps or Apple Maps or whatever? How does it know that there's a crash ahead? Or that your traffic line is red from here to here? it's looking at all the other Android phones that are on the road, right? And when it notices a cluster of Androids slowing down in this particular area, it compiles all that data somewhere remotely, not on your phone, right? And communicates to all the phones, there's a traffic jam in this area. Self-driving cars kind of work the same, like the routing information isn't happening necessarily on the car. The ground level navigation, oh, there's a pedestrian there, that's happening on the car, but the routing, for the most part, is remote. Columbia GRASP data set, I mentioned this to you guys earlier. This is very much in the research phase, but basically what this is a huge database of, let's say you have this, it's a database of all the different ways you can grasp it with different grippers, right? So with your machine vision, you look at what's on the table, it's upside down like this, it queries the database, okay, with this part in this position, how can I approach it? Okay, I found the entry in the database, do this, right? So it's a way to go through a bunch of different variations of grasping a part, but you're not doing the computation on board the robot. You're doing all that offsite remotely and just telling the robot, move this way. Something similar to the Canon bin picking dictionary option, where all you guys at the earlier talked about bin picking. Great. I don't think I need to go over that then, what that is. Is there anyone that doesn't remember or wasn't there? I recognize all you guys. So dipping your toes in, these are products, okay? So if you wanted to explore the capabilities of IoT and robotics, here's some products that might let you kind of ease into it or get some of the benefits of IoT without necessarily diving in head first. So Robotique, has anyone heard of Robotique or not heard of Robotique? Robotique has a product called Insights. It's for UR specifically. This is a cloud-based option. So this very much fits into the sensor, edge device, gateway, cloud, analytics, notification, information dispersal. You install this software on your robot called the UR cap. That allows you to place markers in your UR programs, right? So it allows you to basically set up KPIs from within your program. Then you have the edge gateway, which is the only hardware component of this. It's a box about that big. That plugs into your network. And then their cloud service, their cloud insights service, processes all that data. And if your process goes down, it can send you a text notification. It can show you the uptime, the downtime, the efficiency of your processes, all the different KPIs. You can get to it from any kind of device. So you guys at RBC, you guys are using this. So real quick, this is Alex and Ben from RBC. If you go on Robotics Insights page, you'll see Alex's picture. So he's a power user. Would you mind sharing your experience with the Insights platform?
Yeah. So Insights, like you were saying, lets you track custom KPI, and like one of the things that we've done, we have it on actually all 3 of our robots right now, is we track different steps in the process so that we can see how it's doing. So it's got the built-in one that you can get for free. They have a free version, by the way, so you can literally download this when you get home if you have UR and try it. But they will let you track completed cycles. But then we have a part marking robot. I want to track when the part has been marked and when it's completed that whole set of motion to marking the part. So I can see time difference between different part numbers and that kind of thing. So we actually use it to track all these different statistics on different subsets of the code. But I was actually in a training class last week, and my phone started texting me that our robot was having problems. It was in a protective stop. This and that was going on. So I was able to call in to Ben, and then together on the phone, we were able to work through all those errors and get the robot up and running. And I knew as soon as it happened. So it's real-time reports, and we can see those statistics as well. So we can see it took us 10 minutes to clear the error, but we knew about it the second it happened. So, yeah,
Cool, thank you.
that's kind of how we use it.
Yeah, so not only for production monitoring, but also for support as well, right? A slightly different approach to this, so Moines RPS is a German company. They make software that makes it easy to program a robot offline and kind of simulate your environment, your parts and everything. Being a German company, German manufacturing facilities they tend to be a lot more conservative about allowing any sort of outside connections to their manufacturing data and networks, right? So if they say, this goes to the cloud, sorry, hard pass. We're not going to be connecting any of our production data to an outside network. So they've built a monitoring package based on the idea of keeping it on your local server. So this is not cloud-based. This is more about still collecting the data. What this allows you to do is actually turn your robot or your UR teach pendant into a heads-up display. So all your process monitoring happens on board the robot, and the device where you analyze and pull this up is still the robot. So there's no cloud component to it or Internet of Things. You can connect it to your production network, but there's no outside connection required. So if there's any hesitation about using a cloud-based service and connecting to your process data, this could be a decent option. Iconics IoT Works, this is software. This isn't really plug and play. So this is software that works with all sorts of edge devices, right? It lets you do remote monitoring and control. It can integrate with the Microsoft Azure machine learning. It can work with third-party gateways. This is a software solution. I'm not super knowledgeable about this. Paul, do you have any other information about this or the specifics that are useful?
Okay, so what IoT Works does is allows you to implement a software-based edge gateway. And you're not limited to the types of devices that you want to connect to, so you can connect any different types of devices. And if you implement a cloud implementation, then the IoT Works piece will transfer the data to the cloud. And in the cloud is where you run, you hear this term analytics, but you store data, you run your analytics, and then you also produce all your visualization. So you come back to your mobile device or your desktop or laptops, wherever you want to do it, based upon whatever data you're collecting. But it's a hardware agnostic solution. And it can either be run on a locally hosted server or it can be run on a cloud server. So it's completely hardware agnostic, doesn't care, we don't care about that. And you can deploy it locally or cloud. So just a very flexible solution.
Okay, so it's kind of like that universal remote, but totally on the software side. Not quite. That's all I had, honestly. Like I said, we're barely scratching the surface. You could spend hours learning about edge devices, gateways, implementations of IoT, cloud processing, all that. So, are there any questions?
Do you have any thoughts about where the future of IoT might be? It seems like the production monitoring, remote monitoring, all that's kind of been done already. We're getting more to like predictive stuff. Any thoughts about the future beyond that stuff?
I'll give you my thoughts, and then I'll let Paul give his thoughts, because he's spent a lot more time in the field with this. I think production optimization is the most obvious choice, and it's what has been going on. So like Nest thermostats, Microsoft Smart Campus. I think once people figure out how to reliably do predictive maintenance with IoT, that's going to explode. Because, like I said, how do you know when your robot's joint is about to wear out? It's a little more involved than just figuring out, oh, we have an opening here to shave 5 seconds off the cycle, right? Paul, what do you think?
So Ananda says production optimization, when I think about things like overall equipment effectiveness, OEE, downtime management, those types of things, energy management, consumption of consumables within a manufacturing process, all of those things all lead to costs. And a lot of those have been done for years and years and years on internally hosted equipment. You know, some of you may have plant historians already running in your plant, have had for years. You've got reams and reams of data. And so now all of a sudden somebody comes along and says, oh, IoT, move it all to the cloud. Well, that only makes sense if it makes sense. And so those are some things. What I think is going to happen is I think this industrial IoT thing is just getting started, especially when it comes to discrete manufacturing and robotics type things. Other things make perfect sense. For example, GE is really big into it right now, but they're monitoring things like jet engines and locomotives and wind turbines and those types of things. And so those are really high dollar assets. Right? You take a production machine or a packaging machine or something like that, I think there's still a lot to be learned about what opportunities there are to apply IoT to those types of technologies. And what keeps those machines running if you're using that type of technology. You know, you talk about a robot, and like on a UR, you can monitor the temperature of every single joint. Right? No problem. You monitor, it's very easy, dedicated addresses. But what does that tell you? Well, in a snapshot, it tells you almost nothing. Right? But over a period of time, it might give you some real insights into how that machine is working. And as people get smarter and smarter and smarter about understanding that data, they'll begin to understand that if this type of temperature is being seen in the joint for this type of period of time, then we're creating a situation that's going to lead to a maintenance event, right, that may or may not be planned. And so those are the types of things we're going to learn. I worked several years ago with a company that was trying to monitor performance of AC motors. And they were able to determine by monitoring temperature, bearing temperature, current, and vibration that they can predict the failure of an AC motor 1 week before it happened. To somebody who runs a sequential production line like a bottling company, you're producing bottled water, Coca-Cola. If the AC motor at the last machine fails, unpredictably, then you got a real problem because everything upstream stops, right? And so their ability to be able to predict a week in advance totally changed the dynamics of their maintenance schedules. And so those are the types of things that I think are going to happen with IoT as we go forward. I think a lot is yet to be learned and a lot is yet to be known. But as Manny said, sticking your toe in the water starts the learning process. Does that answer your question? Does that help at all? Sure. Yeah. So, you know, I think it'll be amazing where it goes.